A big part of sixth grade is looking at input-output tables or XY tables and finding a unit rate. Now, it's really kind of neat. A lot of times people do this kind of backward. I'm looking at it saying, let's look at some given numbers. All right, we're going to check to see if it's proportional by graphing it. And we're going to use this dynamic model to try to figure out what the unit rate is by finding the slope, which is something you're going to do in 7th and 8th grade. But let's just find out the way to do it right now and make it easy. First thing I'm going to do, I'm going to graph these 2 points, 3, 9, and 5, 15. So I'm going to look over here, and I'm going to find 3, and go up 9. Notice some of the helpful ideas. If you make a big X with your body, you're pointing to the right and the left. That's where you start. And then you go up. So as long as you can say X, Y, Z, you start with the X, and then you move to the Y. Okay, the next point I'm going to graph is 5, 15. So I'm going to move over 5. I'm going to go up 15, 5, 10, 15. And I'm going to draw a line to connect those points. Okay, the points have been graphed. We see that it's a straight line and it goes through the origin, so this is a proportion. Let's look at this table a little closely. Instead of trying to find the slope with conventional formulas, let's just look in the table. We know that the difference between these 2 points, in the X and Y, between the X and Y parts of the coordinates, are going to be consistent between any 2 points on that graph. So we can do this anywhere we want. Let's do it right here. So going from 3 to 5, did it get bigger or smaller? Well, it got bigger. By how much? By 2. All right, and in the Y dimension, we're going from 9 to 15. Did it get bigger or smaller? Well, it got bigger. So how far is it from 9 to 15? Well, from 10 to 15, it would be 5. This is one more. It's 6. So we're going to look over here and make sense out of this. This is our change in X, our horizontal distance, and it changed. It got bigger by 2. This is our vertical distance. How much did it change in the Y? Well, it went up 6. Let's look over here and see what that really means on this graph. In the X direction, going from this point to this point, it went positive 2, went to the right 2. And then it went in the Y direction up 6. If you look at it right there, you can see that this is a fraction 6 halves. I know it's a positive slope. If I write the word slope on this line, it's going uphill. Positive slope. All right, if we simplify this fraction, it's equal to 3 over 1, which is 3. Let's look down here. If we go change in X is 1, go up 3. Change in X is 1, go up 3. That's the simplified version. Whatever you do, take the X value, multiply it by 3, and we get the Y value. Looking over here, here's the function rule. To get Y, all you have to do is take 3 and multiply that by x, and you can fill in the rest of the table. That's that unit rate. Moving up 3 in the y direction for every one that you're moving in the x direction. And it hits the origin, so it's a proportion. So drawing those triangles in here is a great way to show what the slope is in the distance between the 2 points given, and how that's simplified to make a proportional triangle that's the same over 1 up 3.